What I'm really pleased about is to see, as we've said, so many people here wanting to discuss this, wanting to get involved, and I'm also both pleased and dismayed that a lot of my messages have already been taken. So we're all singing off the same song sheet to some degree, which has got to be a plus. This doesn't work, I don't think, does it? Next slide, thanks. I've got a few bills. Just really what I wanted to do today is not get too deep and heavy into what we do in terms of actual technology developed. Really want to talk about the DMTC engagement model, and then I think in the absence of any sort of case studies, it becomes a bit of an esoteric conversation. So I do want to provide a couple of case studies just to give some context to what I'm talking about. But to set the scene, DMTC is a not-for-profit company. While we are connected to the Defence Innovation Hub, and I'll go through that in a moment, we're an independent, as I say, not-for-profit company. We don't practice our own technology. Our job is purely and simply to create new or improved capability in the industry such that it can be accessed by Defence. So we're part of that Defence industry policy statement. And there's a few words there, but basically we work around broadly in the manufacturing and materials space, but broadening out into some other areas like medical countermeasures and high altitude sensors more recently. So again, it's our job to put capability into industry's hands, and it's the industry's job then to sell that into Defence through the normal procurement channels. Next, thanks. Hope I can offend everybody with this one. This is a slide that was sort of developed back in the DMO days, but it's an interesting perspective on this whole defence innovation area and how it can be very difficult. So there's a bit of a build here. If you can click through it, I'd appreciate it. From the user practitioner space, there's a certain, next one, thanks. Everybody brings their own set of perspectives to the whole defence procurement, defence innovation space. There's the practitioner who are the ones that have got to face the enemy, as it were, and they've got some very, very specific requirements. They've obviously got to have full reliability of the technology. It's got to be there on time. They're going to figure out ways of using it that none of us ever discovered, and so it's got to be soldier-proof. It's got to be fully flexible, fieldable, on time, all the time, that sort of thing. Next, thanks. And again, two more, if you would. So then the acquisition comes in. There's always an acquisition framework. There's a tendency to be risk-averse or certainly risk-aware. There's a capability systems approach, there's constrained budgets, there's all these sorts of things, and I think certainly DiggerWorks was one of the things that's looked to address the dichotomy there. Next, thanks. You've then got industry who'll be providing the capability in broad terms. One more, please. Industry, we're providing those capability into the Defence Force, so it's got its own drivers. Obviously, there's a profit driver there. If the industry's not making a profit, it's not an industry, it won't be in business for long. Industry's always looking for flexibility to innovate, those sorts of things. And as far as S&T and innovation is concerned, if it is going to innovate, it needs its partners to be delivering exactly as advertised. So there's one more group. And the S&T people, one more click, thanks. S&T people tend to take a very broad, no-risk view of innovation and technology. Just give me some money and let me run. I'll be fine. Don't tie me down with project management. I'm too smart for that. I'll figure out ways of innovating that you didn't even believe were possible, and I'll give you solutions to problems you never even knew you had in ways that you never even knew you could spend your money, and then I'll come back and tell you why it didn't quite work and why I need more money to go off and do it again. And I'm sorry, I've got a PhD, so I used to be able to do this myself. So, as I say, I hope I've managed to offend everybody a little bit by that one, but really it's designed to show that there is a lot of different success drivers and a lot of different cultural elements that go into this whole innovation system. And so as a group, I think we've heard different perspectives here today, and that's one of the reasons why we're all here together to see how can we actually make this slide work. Next, thanks. And one more. I've seen different versions of this a couple of times today, so I won't dwell on it. This is lifted straight from the Defence Industry Policy Statement, and the bottom it shows there where DMTC is connected. So we are part of Benjamin's empire as part of the Defence Innovation Hub. We do work with DST Group, and we work very closely with CDIC in other areas as well. But in terms of our close contractual relationship, we're plugged into the Innovation Hub. Next, thanks. Okay, so a DMTC program, it's basically 3 legs to the stool. If one of those legs doesn't exist, then the program doesn't exist. And the first thing we start with is always an articulated defence need. And we've heard this expressed in different ways today, so I'm very glad to hear that. We don't get out of bed unless we can get a defence sponsor, and that can be a financial sponsor, but certainly just somebody that can send people along to meetings and tell us this is what we want. Here is the problem space we want you to address. Having established that, we then need to look at an industrial capability, because DMTC won't be delivering the solution to the customer. It will be our industrial partners that do that. And it has to be an Australian industrial partner, or at least somebody that's prepared to establish an Australian industrial footprint, because again, we are part of the Defence Industry Policy Statement and we're here to support industrial capability. And the third bit, and we often say this is the easy bit, where is the scientific or the innovative capability to support it? And I'm a bit careful to say it's easy when I'm talking to my research colleagues, but I've never met a researcher yet that will tell you they can't do something, and generally they're right. We've got a lot of university and research sector partners around the country, and we can generally find the technical solution to support. So each of those 3 elements needs to be there for DMTC's model to work appropriately. Next, thanks. There's another build here. So that's us in the middle. Again, good stakeholder diagram. Put yourself at the centre of the universe. So we operate with a group of industrial and research sector participants. Together goes up to make the Defence Materials Technology Centre. Next, thanks. We've got a quote-unquote core contract, and that's with Benjamin's team. That's for that basically is lights on money for us. It keeps the overhead of the organisation so that we can operate directly for program officers, and I'll come to that in a minute. But also it gives us the ability to conduct some lead-in strategic work, just to start to address the art of the possible. Go ahead, there's a few more. And we've got a series of individual relationships. The DiggerWorks relationship was the first one, and that was actually Jason was the foundation kernel there, so that was really showed us how we can work with individual agencies within defence rather than having a big block-funded grant, and was a fire and forget model. So we now have a range of relationships with different agencies within defence, and they fund different elements of work that we're doing. So there's Land 2110 there, C5000, which is finalising with Air Vice Marshal Gordon, the Joint Strike Fighter activity. There's a couple more in discussions with Future Submarine, Land 400, and one more. And from time to time, we even get a bit of money out of the States, and it's usually, again, to support their little version of what they want to see in defence industry. So that's where, in the top half of that diagram, is where the Commonwealth comes to the party, the Commonwealth and the States come to the party with resourcing. It's a collaborative model, and the collaboration is not only interacting with one another, it's a co-investment model. So if the next slide can come through. Each of our industry and research sector partners invests cash and in kind as well. So we're all sharing the pain, we're all sharing the gain. And so Josh mentioned before that collaboration can be expensive. I'd actually contend that it's cheap. Each partner and each partner group here is leveraging the contributions of the others. So for defence, you can have a problem solved for 30, 40 cents in the dollar. For an industry partner, it's somewhat similar. And again, if you're collaborating up and down supply chains and you might be working with 3 or 4 different industry partners in one project, it's even less than that. You might be able to get away with 10 cents on the dollar. And we've seen this happen a number of times. In return for their investment, next slide, thanks, our industry partners get to commercialise the IP. Again, DMTC doesn't do it ourselves, we're a not-for-profit. Our job is to facilitate and manage the delivery. If we're not being successful in having our industrial partners selling into defence, then we're not being successful. It's as simple as that. So we're invested in your success, or in industry success. And as Josh mentioned before, our research friends have drivers as well, and so they get rights to the intellectual property for research purposes, but not for commercialisation. So we don't want to be creating competitors for our industrial partners, we want to be creating collaborators and supporting actives. Thanks. Next. Really quick run through, I won't dwell on this. These are our industrial partners, some usual suspects there, some that you probably haven't seen. Next, thanks. And those are the research partners that we're engaged in for their various different areas. We've got the 3 O organisations, ANSTO, DST Group now, and CSIRO. Next one, thanks. And a group of other industry partners, and I'll come back to this slide in a little while. We run a series of industry capability development activities. There's a heap of industry partners in there that I'll bet nobody here's ever heard of. There's quite a few in there that I've never heard of before. And I guess that's the point about the industry policy, is we're trying to bring additional industry partners and industry players into the defence space to provide new industrial capability, particularly into things like the maritime supply chains, when we're all going to be so flat out producing ships and submarines and so on. We simply need to create more industrial capacity and capability. And so that's where this activity comes. As I say, I'll come back to that in a moment. Next, thanks. 3 more clicks, if you would. We measure everything at DMTC. One of the things that we do is analyse where we are in the TRL spectrum. And so this is the resources of the organisation that are directed towards progressing something to a certain TRL level. We don't get involved in early stage TRL much at all, you can see there. And again, if you go back to the policy, that's really where the Next Gen Tech Fund, the DST group, and that's where we expect our university partners to have already made some investment so that we have a proof of concept on our hands. It will simply take too long for an industrial partner's attention span and resource capabilities to progress that all the way through from TRL 0 all the way up to something fieldable. Because of some of the probity and procurement concerns that we've discussed as well today, we don't get much involved past TRL 7. From time to time, we'll do a little bit around. One of the examples is some automated welding that's been deployed into Talos and Forgex and BAE systems, and so we've continued to develop that, and there's been a couple of spin-offs that have come out of that. The bulk of the work we do is in that valley of death, in between about TRL 4 and TRL 7, which is right where the innovation hub sits. So that's it's always nice to know that you're lining up. Next, thanks. Yeah, so okay, we'll keep going, thanks. So that's the scene setting. I think I'm going okay on time, so I might start slowing down just a little bit. I wanted to give a couple of contextual examples because you've heard me talking about how we engage, but not much about what we actually do. So next, thanks. Go ahead, click. So we're involved in the Future Frigate program. We're in contract with the C5000 office. If you keep going there, there's a couple of builds. And I think 3 or 4 more. Okay, that's it, thank you. The objectives there are, we got involved about 2 years ago. We wanted to understand, or the C5000 office wanted to understand what the Australian industrial capabilities looked like in some key areas in order to support supply chain development, in order to support the procurement of the platform, and so we started working on that. As they work through the CEP program or process, and the eventual bidder, or the eventual winner of the contest, our involvement in that program will also change. But in broad terms, you can see what we're there to do. Decrease manufacturing costs, look at material strengths, increasing performance, and trying to link in some design elements to manufacturability of systems, and all in an Australian industrial context. Also looking at fleet availability, and then also to start thinking about what happens when these things hit service. What are we going to do in terms of sustainability and through life support? And so looking at some of the technologies and how do we start to line up in an industrial context so that defence has an appropriate level of competition in the supply chain to procure its products and services from down the track. Next, thanks. A couple of pretty pictures to show the sort of things that we work on. And again, going back to those industrial slides and the research sector slides, our projects in general, we've got a few of them that are a single industry partner, but in general they're at least 1 and usually 2 or 3 industrial partners collaborating up and down a supply chain, and almost always several different research sector institutions as well, and that's collaboration across universities, CSIRO, DST Group, ANSTO, and the like. Next, thanks. Okay, that's snuck in, sorry, that's land. We don't care about land, mate. So. No, we care very much about land, but I'll talk about that a different. So that the C5000 activity is something that we're currently involved in, and that's ticking over. It's 2 to 3 years old. But what I thought I'd also do is give you an example of a more mature program to show how we can deploy that technology through a supply chain once we've undertaken a deep R&D activity. So next slide, thanks. This is going back into history a little bit. We've got a program that involved CNC machining and manufacturability of the JSF vertical tail using BAE Systems as the ultimate the ultimate industrial partner. Next, thanks. 2 research organisations and 5 different universities were involved in that. Next again, thanks. And 11 different industrial partners, all involved in that activity. And what we did was look at the optimised processing parameters for producing hard-to-machine elements like titanium, aluminium, these types of things. All of different capabilities, including cutting tool design, vibration monitoring, artificial intelligence, look at strength and fatigue management in the components, all that sort of thing. And of course, you can see there that there's been such a really broad collaboration across about 6 different projects involving all of those different collaboration partners. Next, thanks. If you look at that as a TRL progression, this was an activity that occurred over about 5 years. One of the keys to developing a vibrant collaborative partnership in this is making sure that you milestone your technology development appropriately, so that at different stages in that you've got off-ramps built in and the industrial partners can take off and use what they've learned in the activities to develop improvements in their own business on their shop floor. So we're very much focused on a TRL progression model of our commercialisation. It's not beavering away, coming up with the eureka moment and then throwing a completed product over the fence to an unsuspecting industry partner. We've got to have the industry partners involved in the earliest stages of the collaboration to make sure that we're providing the appropriate adult supervision to the researchers who, with the best will in the world, can't possibly understand the industrial relevance of the technology they're developing. And that's what the collaboration is really about, making sure that everybody's involved together. So as we progress that through TRL 6, 7, 8, and we didn't get up to 9, we're not going to claim we built the Joint Strike Fighter, but we've developed some quite significant feed-ins to that Australian component of that. Next, thanks. And so the IP model and the supply chain model are really key pillars, enablers of that. Our IP model is the Hub's IP model. It's as simple as that. And that basically allows all partners in an activity to share in the intellectual property in a predefined use field. So BAE Systems doesn't care about manufacturing cutting tools, but it wants to know that the cutting tools that it's accessing will last twice as long as the ones that it was accessing last week. So cost downs in terms of the cost of consumables in a Joint Strike Fighter machining activity have been estimated around $200 million. We can make the cutting tools last twice as long, then they've just knocked $100 million off the cost of that activity. So there's an opportunity for a supply chain partner. Similar sort of story with vibration monitoring and so on. So you get everybody working together, everyone sharing in that intellectual property for different deployment areas, and then everyone's invested in everyone else's success. Once we get that up to TRL 7A, next, thanks, we then get on to how do you deploy that out in the supply chain. Okay, go ahead. And if you just click one more, that should build on its own. Thank you. So, as I said, we worked away on that for about 4 to 5 years, getting back in the TARDIS and go back to the start. We then matured the technology, and we want to say, okay, we've got BAE Systems happy, but there's a lot of supply chain companies in Australia that might have opportunities or could be given opportunities to work. Go ahead. Next, thanks. So what we wanted to do was produce a model whereby BAE Systems could interact with its supply chain, or with a potential supply chain, in a sort of an arm's length model. Everybody could have a look at everybody else's capabilities, and we could use a really nicely structured program to develop that in the supply chain. Go ahead. And we ended up with Axiom Diamol as one of about 8 different companies we worked with, who had never worked in the defence space before, is now in BAE Systems supply chain, because they were able to understand the rigours of working in the defence space. And this is where I bring in our relationship with the CDIC. DMTC works on the shop floor. We work on the hard technology side of things, the CDIC is extremely important in bringing up an understanding in the industrial supply chain sector of the front office capabilities that are going to be required. What do you know about ITAR? How do you deal with national security compliance? How are you managing your intellectual property and these types of things? And so working together with the CDIC, we've ended up creating a new capability in industry, and that's now in BAE's supply chain. And there are a couple of other examples of that as well. Next thing. So going back to this slide that I've shown before, the top 2/3 of that are welding supply chain companies that we're now working with in the C5000 activity. And these are coming out of the oil and gas industry, they're coming out of the power generation industry down in Victoria, they're coming out of automotive and all that sort of thing. So companies that have got good welding capability but don't know anything about the specific requirements of the military maritime sector. And so we're working through with them and saying, these are the standards you need to comply with, these are the productivity requirements. Okay, next, thanks. Just keep clicking through that. So in a sort of modular process, let's just have a look at what your basic capabilities are and benchmarking them. In Module 2, we'll start bringing in the prime contractor. So Naval Group is now involved. Fincantieri, BAE and the Vandia are also interested and will be starting to be involved and say, this is the exact grade of steel we are bidding the C5000 program with, and these are the standards we'll need you to comply with. So before we start introducing a company that's been making boiler steel for the Latrobe Valley, we've got to benchmark them and let them know that there's actually a broad target, and then little bit by little bit we can start targeting that for the exact application. Once you've got them into the supply chain, they've got to continue to innovate. And so that then rolls into Module 3 where they can feed back in and you can start doing more long-term R&D programs. So the first 2 modules are really technology transfer. They're quick, they take 6 to 12 months each. There's a fairly set series of activities that you can run. I know I'm running out of time, so I'll hustle it up. But then to continue to innovate and feed them into more R&D activities and create that local supply chain so our friends in the overseas primes can't say there's nothing worth dealing with in Australia. Defence can hold their feet to the fire and say, yes, there is, because we've seen the data. Okay, next, thanks. Next, we'll just skip that one. So, conclusions. One more, thanks. Somebody before said they didn't like to blow their own trumpet. Well, I'm very happy to blow mine, but the reason I've put this up is if you look at, again, going back to the 3 legs of a stool, you've got an industry capability, a defence requirement, and research. So all the partners need to get something out of it. So awards and recognition and these types of things are a really nice way of benchmarking how you're going. If we're continuing to get recognition for our business processes, the MTC is an ISO 9001 organisation now. We're involved in the CDIC's continuous improvement program. So if we're getting recognition in that, we know our business processes are going okay. We're looking at ISO 44001. Can't find anyone in Australia that can actually assess us against it yet, actually, which is interesting. So I think it is very new. We're winning commercialisation awards on behalf of our partners, so we know that we're actually developing technology. We're getting, there's a couple of letters there from the Army to say, thanks for all this work you're doing, it's really making a difference. So we're getting that validation that our commercial settings are about right. And we're winning scientific awards on behalf of our research sector organisations. So we know that we'll continue to attract their best and brightest because they can continue to do that research that's so important to them. Last slide. Go ahead, just click through them. Josh actually stole a lot of my thunder on this. I was very disappointed. But lessons learned and what does good collaboration look like? I think, as we've said, you've got to have a defence need to begin with. Industry's got to be there, research. Everyone's got to get something out of it. You've got to have a common structure that's got enough flexibility built into it so that everybody knows what they're getting in for when they go into place. Relationships and trust, Josh mentioned that as well. Leadership is absolutely critical, not just in DMTC, but in the organisations you're collaborating with. You've got to have people that are prepared to back their engineers. It's not immediately obvious to a lot of people what they're going to get out of putting an engineer into a research and development organisation for 3 years. If they're prepared to keep doing it, then that's really solid buy-in. Program management's critical. And that's all about culture, particularly, I think, in the universities. Corporate governance is key. continuing a focus on impact of the research, making sure that you're delivering for your partners. And one thing I haven't gone through is DMTC is technology neutral. I'm not going to try and sell you composites if you don't need it. We need to start with a defence need, and then we'll go and figure out what the right approach to it is. And so some research and development organisations will start with the hammer and every problem looks like a nail. And I'm really careful not to do that. We've got to make sure that we keep the practitioner at the centre of considerations, not the scientist. It's absolutely critical. We've got to be responsive to what our warfighters need. Otherwise, we're not doing our jobs. And the others are sitting there. So I know I have gone over by 5 minutes. I appreciate your indulgence. And I think I'm on the panel later, so happy to answer questions. Thank you.